Hi guys, good evening and welcome to another session of the Explorer Series 2.0. Thank you for joining us for episode 2, Adopting a GraphQL Mindset. So today we will be covering the key topics that come with moving to GraphQL, including bootstrapping, scalability, and best practices. So I'm sure you all are keen to know our speakers for today, and it is my pleasure to introduce you to our first speaker, who is our very own in-house expert, Dinisha Tenakul. So Dinisha is a technical lead at GapStars, and he specializes in front-end technologies. He's passionate about designing and implementing secure, effective software solutions. Dinisha's main passions also are JavaScript and UI UX, and he also enjoys discussing how front-end technologies can convert ideas into digital form and how this is associated with human goals. So Dinisha will be covering our first session, which will be on bootstrapping. Our second speaker is a familiar face that you guys might know, and he will be covering scalability. So I'd like to introduce Hasita Leonage from Different Engineering as our guest speaker. So you may recognize Hasita from his sessions at DevFest, his frequent Clubhouse sessions, or his insightful videos covering a range of tech topics on YouTube. He is an avid tech enthusiast and the current VP of Engineering at Different. Hasita has dabbled in a variety of technologies and enjoys speaking about scalability, performance optimization, and the future of software engineering at large, along with how this can contribute to the overall development of Sri Lanka's economy. So without further ado, I'd love to introduce Dinisha to jump on stage and take on the first session of bootstrapping. Dinisha, the floor is yours.
All right. Thanks, Sarah. Let me share the screen first. Hope you guys can see the screen. All right. So myself, Dinisha, working at GapStars as a tech lead. So the session for today is about GraphQL, and I would be doing how you integrate GraphQL into your application. Okay, let's start. All right. So before moving into how you can integrate the GraphQL into application, let's just ask, what do you mean by GraphQL? If you go to their official website, what the official website is saying is a query language for your API and a runtime for fulfilling those queries with your existing data. Now, what do you mean by that? What do you mean by a query language? Let me give an example. So if you Google SpaceX GraphQL, SpaceX people, I hope that everyone know about the SpaceX. So they have provided a public API, a GraphQL API, for you to play around. So this console, it named as graphical. It's provided by the GraphQL, and so as you can see, it's something very similar to Postman for REST APIs. And so this part is where you write the queries, and this part is where, so when you execute the query, this part is where you get the response of that query. Now here it says Document Explorer. So what here we have is the schema, the whole schema of what you can query from the given API. In here, it's the GraphQL API. So let's query some data from the SpaceX and see how you can query and get these data responses from here. So here, let's see. So you have here you can see you have a field called rockets. So let's type rockets. And so when you go inside the rocket, you guys can see. Let me zoom in a bit. So when you go inside the rockets model, you can see that you can have these fields, have this value. So let's say we get name of the rocket and description, and let's see, you have a country field, and you have engines. So engines, again, a object, a rocket engines object. So here you can say you can get the type and you can get the version, right? So once you done with your query, you can click this and execute the GraphQL query. So here, so you can get a JSON object which is exactly the same as the skeleton of the query as an array, right? So here, so you get the name Falcon 1 and the description, the country, and the engine type, the version, everything. Now the best part is, so when you go to inspect element and you go to the network and you run this query again, you can see there's a network call going on called the GraphQL. Now, if you see this request, it's called /GraphQL and it's a post method. But where are these values which you are sending to the GraphQL API? So here, if you see the request payload, you can see there are two fields in the object that you are sending. One is query, one is variables. Here, as we are not passing any variables, so the query is being sent as a string. So, and the response is exactly the same that we are getting from the graphical playground. Now, the best part is, let me remove these engines and run this query again. So as you can see, it's the same API endpoint that you are calling. So GraphQL server has only one API endpoint, which is /GraphQL, and it's a post method again. But the difference being the query which you are sending. All right. So I hope that you have an understanding, some sort of an understanding, what do you mean by query language for your API. Okay, so talking about the history about the GraphQL, so it was founded and created by the Facebook people in 2012, and they have published the first open source version in 2015. So as you can see, it's still new to the tech world. It's like 6 years, but the popularity is being, gaining. So the big companies like Facebook and what else, Pinterest, Netflix, and yeah, so those kind of PayPal, if I can remember. So those kind of people are using GraphQL and integrated the GraphQL into their applications. All right. Now let's talk about why do you need to use GraphQL? So they have the REST API, right? You have the REST APIs and the traditional way of getting the data, and so why do you need to move into GraphQL? Let me give an example. So here, I have a front-end requirement which I need to get an array of users, and the fields I need is the name, email, the department, and inside the department you have the name, and you have a manager object again inside the department. You need to get the name of the manager of the user, right? The traditional way, the old-fashioned way to get these values from an endpoint is you will have a get method and you have a /users and you will have these query parameters. And to get it dynamically, so we will use a field called fields, and you will pass what you need from the user's entity and ask him to include the department details as well. Now the problem being here, so if you can see, the first problem is, so imagine that this use object has 100 fields or like 50 fields, right? So you have the name, address, and etc., and you have the department details, and you have the manager connection is there inside the department, and you have the projects, all those etc. details. But now if you have some sort of a complex object like that, to cater everything what you need from the front end, it will be difficult to only maintaining one API endpoint. So here, so another problem means, so I'm asking here to include the department details as well, right? So, but you don't have any control whatsoever what you need to get from the department object. So here even though that I need only the name and the manager's name, but I'm pretty sure that this will return every details, every data that you have in the department object. Now let's go to the GraphQL. So the same front-end requirement, but this is different, right? So as I have shown you earlier in the SpaceX GraphQL endpoint API, you just type users. I need the users. I need to access users object, and I need the name and the email. And in the department, the users department, I need the name, and from the department to the manager, I need the name of the manager. That's it. It's very simple, and the front end has the full control. The client will have the full control on what he needs to get from the server, from the API. So you won't be overfetching data or you won't be underfetching data, which is quite happening in the REST API when you implement a REST API. All right. So now let's see how does it work, how it actually works, how GraphQL works in the backend. All right. So here, for an example, so I have a client. So here I have a mobile application. So the mobile application asks to from the GraphQL server to get all the author's information from the API. So you will send a query to the GraphQL server. Now this GraphQL server has two components. One is the schema, one is the resolvers. So how schema works is, schema is basically the definition of your API. So it's like this. It's like that you are. It's like basically the definition of the schema, and you have you have all the data which is available on the API. So it can be queried from a client. Now, so imagine, so now the schema is being set. So you ask for author details. Now the schema, in the schema, you have the author details available. Data is available. You're saying from the schema. Now the schema goes to resolvers. So what do you mean by resolvers in this GraphQL world is, so resolvers are basically the responses, basically controls. Basically in charge of the responses of a GraphQL query. So imagine that you, so here for this example, you need the author details and the schema, and it comes to the schema, and the schema has the author. Schema says that you can query author details, and it goes to resolvers, and the resolvers will connect whatever the data sources. Here is a database, be it a third-party API or file, or maybe like microservice, or be it MySQL database, MongoDB, anything, any data sources, and fetch those data and send to the client again. Okay, so talking about schema, so this is how usually a schema looks like in a GraphQL API. So as you can see, it is strongly typed. So that means same as like TypeScript. You need to mention the type of the field. So here, for an example, so I created a movie type, a movie object, which has these 4 fields: name, genre, year, and image. And the GraphQL has 2 types of operations. So one is called type query, and the other type called the mutation. So query basically, so when you are defining the schema in the type query, we usually define all the read operations which you can get from the API. So here I will, here I have a field called movies. So when you query movies, I'm saying that I need to return all the movies from a data source. So the mutation is basically for all the CRUD operations, excluding the read operations. So that means create, update, and delete. So here I have add operation, it's called add movies. The arguments being named are this, and I'm saying when it is done that I need to return a movie object like this. All right. So as I said earlier, so the resolvers is just a plain JSON object. So how it basically matches with schema is from the name. So here you have the movies, and you comes into movies, and when the movies are available in the schema, it goes into resolver, and the movies resolver says that it will return the data from the. So here, so this is for the. So here we are returning data from the database. So movie objects from the database. Same applicable to add movies as well. So you call the add movies, and it comes here, it passes the arguments, and you create an object of a movie, and you save it into the database, and you return the movie back to the client. All right. So once you're done with this schema and the resolvers, you are ready to go with GraphQL. So you just need to query the data. That's it. So you will. So as I shown you earlier, you will have endpoint call /GraphQL. And you just pass the query which whatever you need from the API, which is available from the API. So here I am passing I need movies, and I need only the name and a genre, and you will get exactly what you asked. All right. So let's put all these what we have learned right now into practice and see how we can bootstrap a GraphQL server and get this data into a web application. Okay, let me share my IDE with you. Just give me some time. Confirm. Right. If you guys can see the VS Code. Okay, so I already created a skeleton for this session. So it's called the project called the Movie Maker, and so I have the front end and the back end. So we'll start from the back end. So I have a Node Express server, which is up and running, and I already my data source will be a MongoDB. Yeah, my data source will be a MongoDB, which I already connected to Mongoose. Right now, as I said earlier, so for you to start with the GraphQL server, first you need to create a schema object. So let me create a folder called schema, and we'll start from here. Okay, so I will create a schema called movie schema, and I will use the function called build schema from the GraphQL. Yeah, from the GraphQL. Before going to schema, I forgot to mention. Share the screen yet. Yeah. So if you go to the GraphQL site and go to code and the language, so as I'm using Node.js, so you can get the code snippets for all the different technologies which you can use within GraphQL. So here I'm using Express GraphQL, so the code snippet is there, and also I need to run npm install. This is against my project. Okay, back to the code. All right. So as I mentioned, so we'll create the build schema. So this is an extension which I'm using to highlight the highlight the query syntaxes. So when you type hash GraphQL, it will highlight the query syntaxes. So first I will create a type called movie. So we will have name as a string and genre as a string and here as an int and image as a string, image URL as a string. Okay, now let's create our query types. So the first one will be movies. So when you have field movies, I need you to return array of movies. Then let's create mutations. So the mutation that we have is add movie, and it has 4 arguments. Let me copy this from the be much easier. Yeah. That moment, right? And let me export this. Okay, let's create another query. Let's go as get movies by name. So once you get movies by name, once you query get movies by name, you will again return a movie array. Okay. So this is the basic schema that we have created for application. Now let's create the resolvers. Okay, so as I said earlier, so resolver is just a JSON object. Okay, so the first thing we need to resolve first is movies. So it's movies. I need to return my movie model. See, so here I have already created a movie model for my MongoDB. So it's called movie and it has the same representation as what we have in the movie schema type. And you have a resolver to find movies, and let me copy the other things as it is taking some time. Okay, so here I have two other resolvers. One is for get movies. So what get movies does is, so name comes as an argument, and you will have the movie model from the MongoDB and find whatever matching from the name that you have passed. And at movies, so you have the 4 arguments and you create a movie object and you save it to the database and you return the movie back to the client. All right. So now you are done with the schema and the resolver. Now we need to connect these things and setting up the GraphQL API. So here, let's copy it from their side. Okay. All right. So the movie schema. So I need to tell that what's the schema and the root value is for resolvers. Okay, sorry, I need to export this. Get the movie resolver, and so this part, this graphical is this field for. So if you can remember, so when I showed you the SpaceX GraphQL API, so you have that playground, right? So to enable that in your local server, so you need to have this graphical so this boolean has to be true. All right. Let's start up the server and see backend server. Do not found servers. data model. All right. Let me share the now the MongoDB is connected and it is run on 4000. Let's see that. Let me share the Chrome again. All right. So let's hit localhost 4000 GraphQL. All right. So this is our playground. So this is basically powered by our data and from our database and from our GraphQL server. Okay, let's see what we have. So as I mentioned, the schema is you can find the schema here and you can find the mutations here. So let's start with movies. Let's have what we have as movies in the database: name, year, and genre. So when you run this, there you go. So these are all the movies you can find from the database which are connected. Okay. Now we have the mutations as well. So let's run a mutation and see that you can. So for mutations, you need to mention it as mutations. Sorry. Mutation. Movie. So you have to name. Just add a movie called Quiet Place. Sorry. Quiet Place. The genre. Horror. The year would be 2029. An image. Right, so I have the image with that. Okay, now let's see. Can pass it. Get the name of the. Okay. I've done a small mistake. Yes, the model, it's a number, and here. See. Let me see what it's happening. Schema is correct. Oh yeah, found the problem. Okay, let me start up the server again. Okay, let's see now. Yeah, there you go. So now I have added the new movie, and when you run it, it is there on the database. All right. So that basically means that our GraphQL API is up and running, and you can query the data from the API. So we'll connect this to a web application. So I have created a small web application. Let me share the screen again. So here's my web application. So I already created the skeleton out of it. So I have components called add movies and I have a container called movies. So this is where I need to get the movies from the from the GraphQL API and pass it to loop it in here. And yeah, so let's start with that. So I have used for React, I use React Apollo to to connect with the GraphQL API. So if I can show you. So if I can show you. So this is the Apollo client, the React Apollo client. So you need to run npm install here, and so it has everything. So what you need to do to up and run the client. So I have already done these things. So here, if you can see, so I have the index.js with me. So here I have defined my GraphQL endpoint, and I've wrapped up that with the application with the topmost app component. Okay, so now that basically means that we can use the Apollo provider throughout the application. All right, now let's jump into the container and let's see how we can. Okay, yeah, how we can basically get these values from the GraphQL API. So first, we need to write a query to get the values. We need to write a query to run against GraphQL API. So here, let's create a folder called queries. And I have the file. So here we will have all the queries of our application. So let's first run. Just have all movies query. So let me copy it from the completed project. So we have time constraint as well. Okay. So out of two queries, one is for all movies, same as like what we have queried in the graphical playground, and the other is to add a movie. So here, for you to add a movie, you need to type mutation and define the function. Define the function, and inside that you need to write the query which you have written in the GraphQL graphical interface. All right. Now let's use these all movies and get these values to the system. All right. So for this, I will use so you'll have the hook called use query for this, and get the all movies. And from here, we will have access to the data, whether it is loading, and also if there's an error, it comes to this error object. Okay, let's see. Okay, so we'll see if it is loading. We'll have a tube called loading, or else we'll return method index and have the movie component run. Okay, so let me copy the completed one from there. Okay. So now let's run this and see if we can. It's not okay. So here's my application. So as you can see, the values are coming from the GraphQL, and this part is basically what we are getting from all the movies are from the GraphQL API. All right. So now we have a portion called add movie in here. So let's just I think it's time constraint. So let me show you the completed one and show you how a mutation can work. So all right, so here I have a form called add movie component. So basically in here I create a mutation. So you can have a hook called use mutation, and I will call this add movie mutation, and so it can be called from this add movie function. So here on the on submit of the form, I call the add movie function along with the variables. So I have in the form you have the name, genre, year, and the image. So once I do that, so another best part which is provided by the Apollo client is, so once you do something, once you do a mutation, you have the free, first control. You have the control to refetch some queries as well. So imagine that you are now adding a movies to your database, your list. Now you need to reload all the movies again, so you can see it in here. So let me add a new movie and see whether this will work. So here, let's see, movie. One more thing, so to change the number. Set here. So if you can see the inspect element. So as you can see, so this is one query for the mutation with the variables, and once it is done, you will have another query which you will refetch the movies again. So here you can see the movie. So please bear in mind with the CSS. So this has gone out from the box or from the UI. So anyway, so that is how you basically bootstrap a session. Sorry, how you bootstrap a GraphQL server into your application. I mean, there are many things that you can do with GraphQL. This is like the most basic. The starting point for your GraphQL application. Yeah, so I think that concludes my session for today. Back to you, Sarah. Thanks, everyone.
Cool. Thanks, Dinisha. So now we will be bringing Hasita onto the floor to discuss scalability. Hasita, the floor is yours. And I'd also like to remind our audience, if you guys have any questions that you would like to ask, either during the session or at the end of the session, on your right-hand side, you will find a question column. So please feel free to drop your questions in there for our experts to ask. Cool. Hasita, you can jump on now.
Thanks, Sarah. Hey, guys. Give me 1 second as I share my screen. All right. I hope you guys can see my screen. Cool. All right. Hi, everyone. My name is Hasit Aliyanage, and today I'm going to talk about using GraphQL at scale. So, to tell you a little bit about how I ran into GraphQL, long time ago, many years ago, I was an architect at Millennium IT, which was the name of LSEG technology back in the day. So back in the day, GraphQL didn't exist, and even REST APIs weren't even talked about that much. All we had were things like service-oriented architecture, SOAP, XML. So that was the story. Fast forward a few more years, I worked for a small startup type company called InfoShare. I was an architect there, and this is where I first came across this concept of GraphQL. It was around 2015. So if I remember what Dinesh said before, 2015 was when the first public spec came out, and I think I saw an early version of the public spec, and I looked at it and I ran away screaming because it's completely new. There were no implementations, nothing in production. So we didn't even know how to write resolver. So I thought, no, this is not something you want to touch. So for the next 4 years, I was blissfully unaware of what was happening in the GraphQL world because I was at Cisco Labs, and over there some of the systems were very critical. That was not a place where you could experiment with a new technology like GraphQL. So after that, about a year and a half ago, I was approached by this company called Different. Found the work interesting, made the switch, and when I went into the company, I found that this is what their architecture looked like. This is a very simplified view of the company's architecture. So what you see in the middle right here is our central API. Just call it the API, and it's a GraphQL API. And this is basically the entire data hub of the company. So wherever you want to get data from, all our data sources. So at the top, you see these great data sources like we have a MySQL database, a MongoDB database, various other AWS data sources, third-party API, even files. Wherever you want to fetch data from in our system, you go through this central GraphQL API. And internal application, mobile applications, even other APIs who need data from us, go through this. So that's where we are. And I was by no means an expert on GraphQL at the time. But I did notice something. When you started out with GraphQL, it's fantastic. The developer experience more than anything else is fantastic because back in the REST days, what you have to do is every time you add a new type of screen to the front end, either you have to call multiple REST endpoints to collect the data, or you have to write a new REST endpoint, right? So you keep writing, adding new front-end features, new APIs, new front-end features, new APIs, okay? But when you go to GraphQL, you define your data once in the database, you define your schema once, and you write your resolvers once. Let's say you want to use users, you write the resolver for users only once. And after that, all the queries that you need to use users in, you just craft that query in the front end. It's so easy. Or so I thought. The problem starts up when your number of users go up, when your data volumes in the database goes up, and the number of features in your system goes up, which is basically scaling. As you start to scale, these usual suspects come up. I'm not saying these are the only types of problems you run into when you develop GraphQL APIs, but these are the three main ones that I have noticed. And in fact, these are the only ones that I have actually time to talk about today. The main things are performance, stability, and third is security. Okay, so how did I go about learning about these things? Because I was not a GraphQL expert. This is how not to do it. And this is not how I did it as well. How not to do it is you go to Google or you go to Stack Overflow, you type how to scale GraphQL or how do you secure a GraphQL. And a whole bunch of articles by so-called experts come up. You read those articles, you take what they say as gospel and you do it. Now this thing is called cargo cult programming. I'm not going to talk about what that is, but it is the opposite of how engineering used to be done back in the day. The traditional way of engineering, long before Google and Stack Overflow existed, was that you start with first principles. And the first principles are these. Even though I was not an expert on GraphQL, I would like to think I'm a fair expert in HTTP, networking. Fair level of expertise in databases. Query optimizations, normalization, denormalization, if you're running NoSQL, those stuff, right? Also, expertise in operating systems, memory, CPU, those stuff. And finally, algorithms and data structures. Because no matter what the programming language is, ultimately it is algorithms and data structures, right? So I looked at that and I thought, I am going to use that knowledge to try to think about the problem and come up with my own solutions to these problems. Not that I came up with these problems had fortunately been already thought of by the previous architect. So all I had to do was understand. So I set about understanding this and coming up with some solutions myself and checking after that, then checking the internet to see, have other people come out with those solutions. So the way to think about things is, don't search for what is the best way to do X. Use first principles to understand it, come up with a bunch of solutions, and then search whether other people have gone through those solutions, what problems they ran into, what worked, what not, and then make your selection. So that's what we are going to do today. And it's by no means limited to GraphQL. This way of thinking, you can apply to any technology. Okay, quick refresh. And Dinisha has made my life easier by doing the heavy lifting. But the first principles related to GraphQL language is just this. So you start with a schema and you have a certain shape in which you want the data, which is what you see in the middle. There are two types of ways when you can make the query. What you see in the top is the REST method, and that is also a type of language, right? That's a query language, but it's a flat query language. There's not so much you can do with it. So what you see bottom is the graph query language, and it is a graph-based language. You see, you can request for each entity, you can request different relationships based on a graph that you have defined. So basically, if you look at it, the only difference between the request and the response data are the missing colons, the values, and the semicolons, right? That's it. That is the fundamental idea of GraphQL as a language. In fact, the original specification came up. This is all they told you. So that's the fundamentals of the language, the first principles. The first principles related to the runtime, when you try to execute GraphQL, is this. You have a front end, you have a back end, and on the right-hand side, you have a data source. Now, in the REST world, for every type of query that the front end wants, inside the runtime, you have to write a new endpoint, right? And you have to write queries like select users from whatever, or from MongoDB if you want to get that data from a collection, and get the data. Yeah. In GraphQL, the only difference is what you see in the middle here. You need something to look at a query like this, what you see on the left-hand side. You want to get all users, name, email, and out of the department relationship, you want the name and manager. So you need something to parse, pass, this query and convert it into queries that go into your database. Now that part is handled by usually a GraphQL library. So the GraphQL library will read this query and reference a schema like this. So the schema tells you a user, name, email, department is there, right? Now, the GraphQL library does not know how to call the data. So that's where the resolvers like Dinisha explained comes in. So what you will be writing in a GraphQL thing is, you include the schema and the library, you write the schema, you write the resolvers, that's it. So those are the first principles. Now let's get to the problem at hand. I hope I'm good on time. Like I said, the usual suspects are performance, stability, and security. Let's take performance and scalability first. Okay. Give me 1 second if there are any relevant questions out here. Yeah, no problem. Okay. So fundamentally speaking, if you have gone through your comp sci in university, when you think about performance, you think about several main things: disk and network, which is I/O operations, CPU, and memory. And how do you normally, in first principles, how do you optimize disk and network? First, you try to optimize the data structures so you only fetch the fields that you want. Second, you try to optimize the query so that you only get the records that you want, which is what you normally do with pagination. Third one is you reduce repeated reads, and the standard technique for that is caching. If you want to optimize CPU, you need to obviously optimize the algorithm. And if you want to optimize memory usage, you need to optimize the amount of data loads, right? Now let's see how those things relate to GraphQL. Here's how you do it. Now you can try and take these principles and try to apply it to different parts of this architecture diagram. So let's look at the front end. What can you do in the front end? First thing you can do is you can try to cache relatively stable data. Relatively stable data may be like, for example, in Dinisha's example, genres. Movie genres don't change every day. So that's something that you can cache for a relatively long period. And the reason you want to do that is, I don't know whether you have heard this. There's a saying in software engineering that in computer science, the two hardest problems in the world are naming things and cache invalidation, right? Because what if somebody goes and updates something in the back end? There's no notification coming in a push notification or something in the front end. Then you have to either poll or something has to happen, right? So that's why you have to be very careful about what you cache, because stale data. That's another thing I learned just through experience. There's a rookie mistake people make when they write queries from the front end. Normally, some of you may know that there's a pattern called service pattern, right? You write a service. Let's say you want to get data from a certain API. You write a service object, service class for that, and write some functions. And you reuse those functions in different parts of the front end. In GraphQL, you do not do that, because one of your UIs will require only 2 fields. Another UI will require 5 fields. So if you use a common function, you will be fetching the union of those fields unnecessarily. So what you have to do is, you have to write a custom GraphQL query for every different screen. So that's a rookie mistake. Let's ask ourselves, can we do filtering and pagination for GraphQL? Does the concept apply? Of course it does. Now on the front end, you don't have to worry, because the data filtration is provided by GraphQL. But another rookie mistake is this. You write the GraphQL, but you forget to add filtering and pagination, because GraphQL supports that. You can define parameters into GraphQL queries. You need to do that, and filter or paginate the data. Otherwise, you're going to run into problems as your data load grows. Then again, let's ask, where else can we cache data? First, we can cache it in the front end. Can we also cache it in the resolvers? Yes. Rather than going to the database, because database is I/O operations, it tend to be slow. So if you are frequently loading the same users again and again, it makes sense to keep it here. But here's a problem. In GraphQL, every response is different, right? So you can't be caching all these different responses. The way to do this in GraphQL is, you need to cache specific objects, and you need to have a globally unique ID for each entity. For example, a certain user has a global unique ID. A certain movie, you will have a certain unique ID. So as these resolvers are trying to get data from the database, first it can check, is this user in memory already? Then I use it. Okay. So you can do that. But again, this invalidation problem is there. You have to be very careful with that. How to do that is outside the scope of this discussion, because we don't have a lot of time. And at the data function level, which your GraphQL, your SQL queries are there, your file reads are there, the normal performance optimizations apply. Second thing, stability. Normally, when you talk about stability, what do you think about? Client side and the server side. On the client side, the mistakes that can happen are malformed requests. Also, you can get denial of service attacks or too many requests coming in. On the server side, common things that can happen now, your data source is unavailable. Database has gone down. or your third-party API is throwing you a internal server error 500. What do you do? And the other thing is, your API starts using a lot of resources, so you have slow queries. You need to monitor those. Let's see how these things apply to GraphQL. First thing about GraphQL is this, and I think in Dinish's example also you saw this. When there's a problem, it is not the problem of the server anymore, because the query is now being crafted by the front end. So who needs the debug data is the front end. So whenever you send a response, an error response to the front end, you can't just send an error code and a string. You probably need to send what happened. Did the GraphQL query have a syntax error? Or was it something else? You need to send the call stack as well sometimes. So that's another thing you need to do in GraphQL for stability. Other part is you have to have some tool. Now in different we use Datadog. Something has to be used to monitor slow queries and errors. And this is more important is in GraphQL because of this. At least in the REST world, your server controls how much data is fetched, right? But in the GraphQL world, the client can write a gigantic query, and it will bring the entire server to a halt. So you need to monitor this. And the other part is naturally, just like any API, you need to throttle. When you have a large number of clients or large number of people sending lots of queries, you need to do that. Finally, like I said here, for the debug info, the resolvers need to send meaningful info into the front end as well. Because here's something that can happen. Let's say you are getting the users from your database, but the details about the movie, maybe you are getting from IMDb API, right? And when you send the response, you have the data for the users because it's available to you. But now IMDb is not available, you can't get movie details. Now what do? You can't just send the 500. You have to say in the 500, the problem is not your MySQL database, but the problem is third-party API. So that data has to be included. Right. That is stability. 2 out of 3. Finally, security. Here are the normal things that we think about when we think security for an API, GraphQL or any other API. Authentication. Normal technique is you use tokens. Authorizations, which is once you get into the system, what data you can access and what data you can change. Finally, vulnerabilities. These are based on the libraries that you use. You have to keep your libraries up to date. And you have to think about denial of service attacks. And you have to think about this old vulnerability, which is SQL injection. And I'll tell you why I'm talking about SQL injection for GraphQL. How does this apply? Let's take our diagram again. Do auth tokens apply? Of course it does. Just like any other API, GraphQL is just an HTTP API. API tokens apply. And when you're using a GraphQL library, that can also introduce vulnerabilities. So you need to keep this one up to date. And you probably need to subscribe to their newsletter or something and figure out when they tell you, tell that there's a vulnerability, you need to update this. Permission checking, there's a difference. Now, normal REST APIs, permission checking happens at the entry point of the endpoint. But in GraphQL, you can't do that because your application doesn't know. Only your GraphQL layer, the resolvers know what data you need. So you need to have the permission checking in the resolver layer. So in common resolvers, there's a way you can pass the context object into the resolvers, and inside that you can pass the permissions available to the user and do it that way. Now, why did I talk about GraphQL SQL vulnerabilities? Now, there's a certain pattern called the almighty root resolver, ARR. So what that does is it takes advantage of the join capabilities of a relational database. Now, normally in GraphQL, we have a n+1 problem. I'll go back 2 here. There's a, I'll go back 3 here. There is a security, what am I saying? There is a performance issue I didn't talk about. Now, if I want to get users and departments in the SQL world, I can write a single SQL query, right, with a join in the middle. In GraphQL, you have to call multiple resolvers. The users resolver will call a separate SQL for users. The a department resolver will call a separate SQL for departments. So you lose the advantage of having joint queries. So some people solve this by writing this thing called the almighty root resolver. What they do is they traverse the abstract syntax tree of the GraphQL query and they dynamically create the SQL. Now the disadvantage of this is if it's a dynamic query, you can't use prepared statements. And if you can't use prepared statements, you can't use parameters. So obviously you are introducing SQL injection because you are concatenating strings. So that is not a good idea. So those are the things you need to think about security. Obviously, there's a lot more, guys. A lot more in performance, a lot more in security, a lot more in stability. But in the interest of time, these are the things you have. And I will do a very quick recap. Caching using a global unique identifier, but be careful with cache invalidation again. Filtering and pagination. Reporting detail errors to the client because it's the client or the front-end user who has to debug the query. Implementing throttling, rate limiting, just as usual. Set up monitoring and alerts for GraphQL API because slow queries, you can get a lot of slow queries. Authentication tokens, usual thing. Check permissions at the resolver layer and be wary of using dynamic query building because of SQL injections and you can't use all the other advantages of prepared statements. And finally, now that you understand these techniques, now you are ready to go on the internet and search what are the libraries available, how do I do it. Apollo client will come up, Apollo server will come up, various other things will come up. Yeah, that is it, everyone. Thank you so much. Back to you, Zara.
Thanks, Hasita. Right, I can see that there are quite a number of questions that have come in here. So I'll pass it on to Hasita and Dinisha to jump on and answer your guys' questions. If you do have any more questions, please do send them in.
Dinisha, you wanna?
Let's start with the first one, right? So the not dev person asking if someone inject a GraphQL query from front end via browser tab like this, at which layer this is resolved. So this is calling entity one, inside that again calling entity two, inside that entity one. So this resolves at in the resolver period. So if you so before that, so we need to see whether in the schema definition whether we can whether this entity one being defined in there, and after that it goes to the resolver. So then the resolvers see whether this from the entity one you can get the entity two, as Hasita told. Like I mean,
it's a recursive call of resolvers.
Yeah. So go into data sources and get those things, and whether this can be resolved. So it happens on the resolver level.
I think Kasun has a question above that. What is the recommended GraphQL server? It's moving around, no? GraphQL server, Apollo, Express.
Yeah,
all right. So I'm going to expressly avoid answering that question because it depends and you need to figure that out for yourself. But I will say different is using Express GraphQL because we are still reluctant to rely on Apollo because with Apollo comes its own bugs and there are certain amount of debugging you won't be able to do. But that my understanding of that might be dated, Dinisha. You might be able to add some more.
Yeah. So I usually use Express GraphQL. So Apollo. So even though that I didn't get a chance to use the Apollo GraphQL, but I mean, yeah. So based on the so as you said, I mean, if you don't need any third party to have their bugs into an application, so you can go with the Express GraphQL, but it's based on your preferences basically.
I will say though, if you are experimenting, do go ahead, go crazy, but try to be careful before you put it in production. Is all I'm saying. Who's next?
Hasita, we have a question for you from Dehan.
All right, I can see it. So how does GraphQL tie into the world of microservices? REST normally ties very well with route-based microservices resources architecture, allowing us to scale up selected REST resources by introducing more instances. Is something like this possible in GraphQL world? I will give you the textbook answer and then I'll give you my answer as well. So the textbook answer is your microservices, you can keep it in REST or any other model because GraphQL, the advantage of GraphQL is its ability to reach out to multiple different data sources and stitch together a single response, right? So if you think about microservices, that is what you call the API gateway layer, or some people call it the BFF layer, the backend for front end layer. So one way to do that is your GraphQL is the API gateway layer. Your data sources can be any old API you want. My personal answer is right now, at least in different, we have not really required to go into microservices because we are following Martin Fowler's advice, which is monolith first. You start with a monolith, and as you need, you factor out microservices, and we just haven't needed it. Hope that answers your question, Dehan.
Got a lot of questions coming in fast, so I think I'll make it easier for Hasita and Dinesh. I'll make it easier for you guys, and I'll help you guys along with the questions. So I think the next one is from Chamit Madhusankar.
Is it beneficial to move to AWS AppSync GraphQL in production? I must be honest, I am not familiar with AppSync. Are you, Dinesh?
No, not me even.
Unfortunately, Chamit, we won't be able to help you today. Sorry.
Right. Next question is from Kasun Vithanage, another one about Join Monster.
What's your opinion on Join Monster? You will probably need to explain what that term means, Kasun.
In the meantime, I think we've got another question from Kasun right at the top. Recommendations on the database side.
You want to take that, Dinesh, first?
Yeah, so let's see, is there any recommended way to reduce the load on the DB side on the resolver? For example, if I only want to fetch query, use first name, there's no point of fetching all the other fields. Yeah, so that's a problem that even like we face sometimes. So even though that from the front end you only need the first name, but sometimes there will be times when you don't have the time to change the DB layer to get only the first name. So we usually get all the details from the user and pass it to the for the front end. But I think one can mitigate that being like if you have dynamic queries. So whatever you are passing from the front end. So if you have the select portion dynamic. So that can be somewhat mitigated, yes.
Hasita, you have a take on that?
I was just looking for this Join Monster, but yeah. So there are two sides to this. This is the main reason that people try to do generate dynamic SQL queries just because they don't want to load the data. But it just happens to be one of the trade-offs of using GraphQL. It's not such a big deal if you're using a NoSQL database, because in NoSQL, every query gives you the entire object. Now, this is how it works at different. So we have a MongoDB database. So even no matter who asks for the user's first name, you get the entire object. So it doesn't really make a difference whether we use GraphQL or not. So until Sahra gets back, I'm going to have a look at what the Join Monster is. It is a product. Translates GraphQL to SQL. So that is the thing that I told you about earlier. Some people call it the almighty root resolver. So this must be using the root resolver to go through the abstract syntax tree and generate the SQL. As long as it works bug-free, that being a third-party library, I think it's great. But do look at how they try to mitigate SQL injection. Beyond that, I think I don't have too much of an opinion on it. Hope that helps, Kasun.
Just running down some of the other questions. We have one from Chamit Madhusankar. No, sorry, that was already asked. The next one is from Rif Khan asking regarding GHI. Mohammed Rif Khan.
Federation GHL GHI. Dinisha, you are familiar with that?
No, so I'm Googling it right now. Federation.
Perhaps I think we are not qualified to answer that, because this is like going deep into GraphQL, and that I think, given that each of our talks are 30 minutes, we probably don't have the time to go into that level of detail. Who knows? Maybe we'll arrange another advanced GraphQL session 3.0.
Episode 3. We have another question, guys. Just want to ask if you've already answered this. Ways to reduce attacks on deeply nested queries.
Let me try to see if I can see that. So deeply nested queries. This becomes a problem if you open up a GraphQL to users you don't trust, right? Because if it's your own development team and your front-end developers who access it, you can obviously through pull request reviews, code reviews, you can make sure you don't go into like 10 nested queries. Beyond that, I think at the resolver layer, when you write it, you can actually determine the number of levels you have gone in and maybe throw an error. But I have personally not done that, to be honest. Maybe that is a way you can mitigate that.
But still, I mean, as you said, it's based on the so it anyway can be, controllable in the front end, right? I mean, so if you have your own development team, as you said, so usually go into that deep when it comes to GraphQL. So you always, find the easiest way to, get the data, not like, go into deep states, and yeah, so it's tend to, break the applications as well.
Cool. Next question is from NodeDev. Assuming book and author entities, if we pass infinity times, will it crash the server?
Where about that question is? Oh, no. Assume book and author entities, if we pass infinity time, will it crash the server?
If you have a caching layer, so I mean, can be kind of like, I mean, can be get that, but
I think he probably means like this: root level author's books, but inside the author's books, author, inside that author again book, like that. Well, it theoretically resolves, and it will probably keep resolving until you run into something like a circuit breaker you have set in the number of levels in your resolver layer. But personally, like I said, I've never come across that problem before.
The next question we have is from Nishant Kumara. In the CQL, is there any specific method to handle the authentication and authorization, also scopes?
I think that is what we already discussed, right? Authentication, it doesn't make any difference because HTTP APIs, whether it's REST API, SOAP, or GraphQL, same principle applies. So use an authentication token. And assuming it's like a JWT token or something, you will also have certain scopes and permissions attached. So those things you have to check at the resolver level. Because it's at the resolver level, you only know which record and which field you are trying to fetch. I hope that helps, Nishant.
Next question is Yachita Sandruan. GraphQL is a specification by Facebook, right? So what is the role of GraphQL library there? Is it an implementation? Right at the bottom.
Right at the bottom. I'm going to scroll to the bottom. Yachita Sandruan, right. GraphQL is a specification by Facebook, which is yes. So what is the role of GraphQL library? Is it an implementation? Last I heard, and my knowledge is dated, it is a reference implementation. Dinisha, correct me if I'm wrong.
That I'm not aware of, Hasita.
So you're probably talking about the Facebook's GraphQL library, I think, Yajita. So I think that is a reference implementation, but since GraphQL is just language and a specification, it doesn't stop other people from developing their own implementations as well. But to be honest, I really haven't, this is a fault of mine, I really haven't gone underneath Express GraphQL and looked at what the resolution layer is built on. So sorry about that.
He also has a question below that. Hi guys, with GraphQL, can we handle transactions properly? For example, transaction management.
That is orthogonal to transactions, because the starting point of transaction in GraphQL is basically a mutation, and the mutation doesn't care. So when you come to the resolver layer, there will be some function, and inside the body of that function, you will be starting a transaction and finishing a transaction. So that is your database layer. So the answer is you can. Just like any other API system, you can use transactions.
Yeah, so it's nothing to do with the GraphQL. I mean, it's basically it's basically another function in the resolver layer, right? So imagine that for an example, you do one after another, like you add something and you update something within a transaction. So I came across this problem, right? So there you can have two mutation functions, or else a wrapper and have a one mutation function doing the both mutation at once in the resolver layer. So it's basically based on the requirement. And yeah, so as Hasid told, transaction basically can be manageable in GraphQL.
Right. We have a question below that from Nishant Kumara. What are the limitations in GraphQL?
So one thing I found is working with GraphQL is data logging, as Hasid told. So I mean, as it is like it's a single API endpoint, and it is not sending the exact problem where the problem occurs. So you need to the it's not a limitation, but I mean you need to have a good error handling when it comes to GraphQL. So you can get the actual error output where it occurs, the error occurs to the front end. And limitations wise, that I can think of.
Well, one thing I can think of is, I think somebody else already asked this, we are always overfetching in the backend. We are fetching exactly what we want in the front end, but in the backend, we are always overfetching because the resolvers are generic. So there's nothing you can do about that. Beyond that, the other thing I think is a lot of people are not used to organizing the code in GraphQL implementations. Because if it's a REST API, you know how to do it. MVC, various patterns are there. But in GraphQL, it's not really established how you want to organize your code structure. It can become spaghetti very soon if you're not careful. So that's something I have seen, Dinisha.
Another question at the bottom from Gayan. What's a DTO?
So I think it's maybe related to REST API DTOs. REST DTOs.
I am unfamiliar with this in reference to GraphQL.
Yeah. So I think maybe he's referring to DTO as into schema, GraphQL schema. Maybe is there any? Maybe I don't know. Maybe something like that.
Yeah, somebody else has asked about ORMs as well. I just remembered. So again, that is the database layer. So you can use an ORM, a function in an ORM to fetch the data for the resolver. So when you go into a resolver function, the body is basically you use your ORM and get the user data. That's possible. There's no problem doing that.
We got a couple more questions up top. One from Shafreen Anfar. Any advice when it comes to scaling GraphQL backends which support subscription operations? Asking because unlike query and mutation subscriptions has state.
Yes. So subscriptions, I think we won't have the time to cover in it. Um, that can result in way more data getting transferred to the front ends without the front end actually asking for it because it's subscription based. Scaling, well, obviously you can scale it in a generic way. So the way we scale it at different is horizontally. We just have auto scaling groups in AWS. We just spawn up more and more of these nodes processes. But whether there are subscription specific ways of scaling at the moment, I don't know. Um, that is something that I have to do some research on, unfortunately. Dinesh, I suppose you are probably in the same boat.
Yes, yeah.
Okay.
Right. Another question from Kasan. Also, do you think using Hasura is beneficial when working with GraphQL? It's also a product that translates GraphQL to effective SQL queries.
Same as before. I don't know, because we are talking at the principal level. So once you have understood the principles, what I would suggest you guys do is, then you can do the Google search for Hasura or all these other like Monster Query, Monster Join. See how they work. Look at inside what the problems are, and then decide for yourself. Is the best thing I can tell you.
Yeah, so even when you go into the documentations of GraphQL, so they have, I mean, for each languages, they are basically, supporting how they, you need to implement those things and what are the libraries that we support. So you can find, I mean, there are lots. So, I mean, so as Hasid told, like, it's based on the preference and based on the situation as well. Like, so if you need to kind of like start up GraphQL, like, I mean, advanced, so you can, go to Apple, some sort of a server and, start it up. So something like that. So it comes into the preferences and also it comes into how the project be like. So it's based on the preferences, I would say.
We have another question, and I think we're going to have to wrap up the question session maybe in about 10 minutes. So because we've already gone a bit over time, but I'll try to accommodate all you guys' questions. One from Samira, what do you think about gRPC over REST for intercommunication of microservices?
Let me find that one.
Yeah, it's Samira Madhushan has asked the question.
Samira with the I or Samira with a double E? Not showing up for me. Can you read out the question again? Then maybe I can just answer.
What?
I don't know. I saw it.
What do you think?
What do you think about gRPC over REST for intercommunication of microservices? So that is basically not GraphQL, right? That's a completely different thing. I am not sure how to answer that, unfortunately. Sorry, Samira. Let's give the opportunity to somebody who has a GraphQL question for now.
Cool. What problems you have seen when you are going to replace an existing system to GraphQL?
Many.
By Krishan Madhushankar.
Many. And the worst possible way to do this is as a big bang. You start writing a new node service or new boot, Spring Boot or whatever it is you are using. You start writing the whole thing in one go, disaster. Because it's going to take a long time for you to stabilize a system. So the best way to do it is piecemeal. And maybe what you can do is you can pick a few read-only get endpoints, like get rest endpoints, and slowly start transitioning them into GraphQL endpoints. Maybe you can embed the Express GraphQL library within your existing Node application or your corresponding Java application, whatever that may be, and slowly start migrating. I think that's the best way to do it. Another way to do this is you place the GraphQL in front of your API. Obviously, it's going to slow things down, but that's another way to do it. It's a bit simpler. So rather than your client coming directly to your REST APIs, it goes to your GraphQL API, and your GraphQL calls your REST API. Dinesh, anything you want to add?
Dinesh, anything to add on to that?
I was about to say the same thing. Like, so even like so I have the experience like you kind of like have a separate API, GraphQL API, and from there you start to get these REST endpoints and get the data from there. So initially we started like that, and I mean from time to time you basically replaces those things. And another thing being how you can so thinking that you can replace REST is with, so you can start with the front end as well. So imagine that you have kind of like a complex web application, and see whether that what are the places which you can basically it's not impacting a lot in your system, right? So you can start from there and see whether what are the entities which will be impacting because of those things. And we can have a separate GraphQL API for only for those things, and from there onwards we can time by time you can basically convert all these REST API endpoints to GraphQL. But having said that, so even the project that I was working, we still have the REST API and along with the GraphQL as well. So we didn't get a chance to fully basically go from REST API to GraphQL. So when there are projects like which is running for years, and when you need to transfer all these REST API into GraphQL, it's a hectic I mean kind of like and time consuming thing, and maybe like maybe it's beneficial for long run and for the development and for the technical wise, but you need to think of the people who owns the project as well. So yeah, that's
Right, just going to go through maybe one or two more questions, and then we are going to call it for today. Another question that we have in is, end users can alter the query and send the request from browser. And I think it's best if one of you guys take the question. Node Dev has asked a question regarding end users and the query.
Node Dev. That is the nature of GraphQL, and that's why you put all your safeguards on the server side, because when the client is your client, whether it's a mobile application or a browser, it's in the hands of the end user. And if the end user is malicious, they can intercept the query and they can do anything you want with it. So that's why the safeguards, like I said, the circuit breakers, throttling, all these things you have to implement in the backend side.
Okay, one more question. Isn't error handling also better in REST, and can we consider it a limitation to GraphQL? Lakmal has asked.
Not really, as long as you send all the details to the client. It puts more load on the client. So back in REST days, if something breaks, the backend developer gets a call and you have to go and look at the SQL query or the logs or whatever, right? But here, if something goes wrong, it's the front-end developer who has to keep debugging. So as long as you send the necessary information to the front end in the error payload, it's not a problem. I don't think it's a limitation.
Cool. Right. Do you guys want to take any more questions? I think we have about one or two more, or shall we call it?
I think I see one interesting question. Shafrin asks, did you guys use a special data loader to solve the N+1 problem? So this N+1 problem is where you, in the REST world or SQL world, where you can get everything in a single query, but you have to send all kinds of query to collect the data to build a single response. There are some data loaders. I think GraphQL has its own data loader that provides you with batching and caching out of the box. But again, I haven't used them, and I'm reluctant to use them until I see them used in like critical production systems. So that is where I am at. That sounds like a wrap, right, Sahara?
Right, sounds like a wrap. Thank you guys so much for sharing your knowledge with everyone today. Thank you, Dinisha and Hasita. And of course, to our audience, thank you guys so much for joining us for episode 2 of the Explorer series. Thank you very much for your questions. To answer what a lot of you guys have been asking, we will be sending a recording to all our attendees following the closure of the session, and there will be a recording posted onto YouTube as well. Yep, stay tuned for episode 3 of the Explorer series, which we will be hosting hopefully next month. And I think that from everything, maybe we should have a Q&A session sometime soon as well with the amount of questions that have come in. Right, sounds good. Thank you, everyone, and have a good night. See you then.
Thanks, guys. Bye.
Thank you. Bye-bye.
See you. Bye-bye.